Welcome class. Thank you for joining me for the beginning of 5.3. So in the last section we talked a lot about factored forms of polynomials where we could tell a lot about what was happening with that polynomial. So now we're progressing to the next section where it's actually our job to make the factored form of these higher powered polynomials. Now, this first section, you've actually already done. Back in chapter 4, we discussed how to pull out a GCF and then use a zero product property to find the zeros of these polynomials. So, again, we're just going to review these first two. However, it's something that you saw last chapter. So, for our first one right here, the first thing that I notice is that there is an x in every term, okay? So because there is an x in every term, what that means is I can actually pull that x out. So when I pull an x out of x cubed, I get x squared. When I pull an x out of x squared, I just get x. When I pull an x out of an x, well, it's gone, and I'm just left with the number. So notice, once I've pulled out that x, now I have a quadratic left that I can factor. And again, factoring a quadratic trinomial means we're going to get our two parentheses. So we need something that multiplies to negative 18 and adds to negative 3. So hopefully you remember those x's come from that x squared. And to find what multiplies to negative 18 and adds to negative 3, you're going to get a negative 6 and a positive 3. Now, once we have this completely factored into those sections, now this is where we're going to use the zero product property. So this is going to produce saying that x is 0. That's going to produce an x minus 6 equals 0. So x equals 6. That is going to give us an x plus 3 equals 0. So x equals negative 3. And those are going to be our three solutions. All right. So again, something we've already done, just refreshing us to make sure we remember how to do this. Now in the next one, a little bit more interesting because not only can I pull out the variable, but notice each of the numbers in it, 3, 6, and 9. Each of those numbers is divisible by 3. So I'm going to pull a 3 out, and then notice x to the 4, x to the 3, and x squared. So the other thing I notice is this time the smallest exponent that I see is actually x squared. So that means I can pull an x squared out of all of these. So let's take a look at what we have left. So I'm looking at the 3x to the 4. Well, if I'm dividing 3 out, that means that the 3 is gone. X to the 4, and I'm dividing x squared out. Well, 4 minus 2 just leaves me an x squared. So negative 6, and I'm dividing 3 out. Well, that's going to become a 2 then. So I'm going to have a minus 2. X cubed divided by x squared. 3 take away 2 will just leave me the x. Negative 9, and I'm dividing 3 out. Well, that's going to become a 3 then. And x squared, I'm pulling the whole x squared out. My variable is out of that last term completely. All right, so looking at this, now we have a quadratic trinomial left. So that means from what's left of my parenthesis, I am going to be able to make two parentheses from that. This x squared is going to give me an x and an x. Two things that multiply to negative 3, add to negative 2. We're going to get that. All right, so this right here, the 3x squared, I'm going to set that equal to 0. Well, if I divide by 3 and square root, I'm going to get x equals 0. Here, x minus 3 equals 0 is going to give me an x equals 3. x plus 1 equals 0 is going to give me an x equals negative 1. And so these are going to be my solutions. Now, something I do want to pick up on to refresh your memories. Notice how this one has a squared in it right there. So this is going to have a multiplicity of 2. So don't forget that little aspect as well, okay? When you have powers on your zeros, remember that's giving a multiplicity to that 0. All right, so again, that's just a little review section to make sure you are still comfortable with factoring, such as that. Now we're going to move on, and we're going to look at this. All right, x to the 4 minus 10x squared plus 9 equals 0. Now, we've never factored a quartic function before. However, I want you to notice something, okay? When you have an x to the 4, x squared, and a constant term. So, x to the 4, x squared, and a constant term. When you have that set up, you can actually use a substitution, okay? We're going to substitute that. We're going to substitute a in for x squared. And I want you to notice what's going to happen here. So if a is x squared, that means x to the 4 would be a squared, okay? Then if a is x squared, then that's just going to be a minus 10a plus 9 equals 0. So we're just making a simple substitution. Now, the reason we're doing this substitution is because notice what I have, okay? A squared minus 10a plus 9. That is a quadratic trinomial that I know how to factor. This a squared comes from a and a. This 9 comes from either 1 times 9 or 3 times 3. However, if it's going to add to be negative, we're going to need those, okay? We're going to need both to be negative. So, I've completely factored that. Well, now the interesting thing is because of that substitution, we can't leave it in terms of a, okay? Solving for a really doesn't do us any good. So what I'm going to do is I'm going to put x squared back in to my polynomial, okay? So here I've made that substitution twice. So here going from x's to a's, then I had to take those a's, turn them back into x's, or into x squareds, I should say. Okay, so notice how that let us make a quartic factorable. By making that simple substitution, it turned it into a quadratic we knew how to factor, and now we just have to put those x squareds back in. All right, now the interesting thing here is when we do that, notice now that we've put the x squareds back in, notice in this example now, we're left with the difference of squares, okay? That x minus 1, remember that plus and minus relationship? The x squared minus 9, remember that plus and minus relationship? So do be careful when you substitute back in, sometimes you're going to have differences of squares that you need to sort out, okay? Because look that it was able to factor again once we made our substitution back. And now we have to go and work with every one of these pieces. So that x plus 1 is going to give me a 0 of x minus 1. The x minus 1 equals 0 gives me a 0 at 1. The x plus 3 gives me a 0 at negative 3. The x minus 3 gives me a 0 at 3. And those represent my 4 solutions to this quartic function. Okay, now I'm going to do another example of this for you to help you be more comfortable with this, because I realize brand new thing, right? So let's take a look at this one. Now, the trick I've added in here that you should remember about factoring is whenever you factor, you absolutely always need it set equal to 0. So here, don't forget that basic skill of just making sure it's set equal to 0. All right, and now we're going to make that substitution. A equals x squared, okay? So that means this x to the 4 is giving me an a squared. Oh, I'm sorry, there's a typo there. Those should be squared. I apologize. So minus 3a, and then minus 4 equals 0. All right, now we can take this. This is a quadratic trinomial that we know how to factor. This a squared gives us an a and an a. Two things that multiply to negative 4 and add to negative 3. Minus 4 plus 1. All right. So now that we have this, now I have to make the substitution back. Okay, we can't leave this in terms of a's. We actually have to take this back to the x squareds. So this is really x squared minus 4, x squared plus 1 equals 0. Now notice x squared minus 4. Notice that that is giving us a difference of squares. That plus and minus relationship, x plus 2, x minus 2. However, this x squared plus 1, that is not a difference of squares because it's not a difference. You are adding. So that one you can't do anything with. Okay? So now we have this. So let's run through now that it's completely factored. Let's get our solutions. So we have an x equals negative 2. This x minus 2 equals 0 gives us an x equals positive 2. Now this one is going to be more interesting. Okay? When we have that left, well, we should remember back from chapter 4 that we can solve this using square roots. So x squared is equal to negative 1. I go to square root both sides. Well, remember, we can't exactly take the square root of a negative. So if you recall here, oh, and I miswrote that, I'm sorry. Once I square root, that should just mean x. But when we try to square root a negative, remember we're getting imaginary solutions. Okay? So that's one thing. Don't forget that when we're solving these, sometimes we can have imaginary solutions. We saw that back when we were constructing polynomials. So this time, our 4 solutions, negative 2, positive 2, then plus or minus I, which you won't see graphically, but are 2 imaginary pieces to the solution of this polynomial. So, thank you so much for joining me. Now, please make sure you have all of this written down, and then next time we'll come and work on our practice work.